Hello and welcome again to the module number 2 of Practical Guide Junior to GIS Expert Training Series, and today we're going to look at how we can work on flood risk assessment project. And actually this project has been designed to cover today's module objectives, which is to look at data management techniques in GIS, spatial and attribute queries, geoprocessing tools, quantitative and qualitative data visualization, layer properties, styling, symbology, and labeling, and at the end of the day, producing a final layout map. So here is our today's project title: Flood Risk Assessment at Msimbazi River Basin. The Dar es Salaam City Flood Risk Management Committee is implementing flood risk assessment for the community settlements and public facilities near Msimbazi River Basin, and you as a GIS specialist are requested to develop a flood risk map of the particular area. So again, this is a GIS task, so you need to have data. So we need to have Msimbazi River data, we need to have administrative boundaries, we need to have buildings and other data layer that we would wish to visualize them within our map. And also we need to have a software. So coming to the stages of how you can start your project, these are the first stage. You need to have a QGIS software, and you need to find the needed data for your project. We have administrative boundary data that were to be downloaded from Diva GIS site, but given the fact that we have already downloaded this type of data from the first module, so we assume that you have the data within your computer system. Well, what we need is the Msimbazi River data, building alongside the river, roads and other facilities that are nearby the Msimbazi River Basin. So we need to download this data from the hot export tool. So this is the link. You can just try to initiate the link. Well, let's see how we can download river data and the land use data from the hot export tool. So let's start by naming our export as Msimbazi data, and you can give a description. For instance, this is flooding risk project, and then we can choose the format of the data that we want. For instance, let's go with the GeoPackage. Then we can select the data that we want. We need buildings, we need emergencies, we also need humanitarian, healthcare, land use, natural and water. Also we need transportation and public and power. So after that we can then go to next. But before going to next, we need to establish the boundary of the data that we want to download. So let's choose, our data is in Dar es Salaam, so let's choose an area where our data is. So okay, this is our area, so we can just choose to draw, and we can draw we can just draw the data that we want. For instance, that one. Then we have to click on next. This is the summary of our data. Then we have to click on create export. So that's our export, and we should wait until the running is complete so that we can download our export. Well, now that our export is complete, we can just click on Msimbazi data package to download it. So let's click it and download it. Well, after downloading your data, now let's try to import our data to the QGIS software. So we just have to click on vector and browse to the location of our data. For instance, this is my data from Symbology data. So we have downloaded the geo package, as you remember. So let's click it and click open. Then we can now click add to load. Well, now we can choose to add the data type that we want, and for this case, because our project is dealing with a network feature, which is lever, so we can just choose the lines, and also we'll need land use type and building that are being represented with polygon features, so we can also choose the polygon and click OK. Now we can click close, and this is our data, as you can see. So let's try to go to this data and start the data management techniques. Okay, here is these are linear data containing lines presenting roads, rivers, and streams. Now that our focus is to have river data, we can filter this data. This is part of data management techniques. We can just filter this data to remain with river and streams. For instance, by right clicking the layer and go to filter. Okay, this is a query by attribute tool. So we can just choose waterways because rivers and streams are in waterways. We can just choose waterways is equal to, then we can choose samples from here. For instance, we can choose is equal to rivers and put a boolean or waterways is equal to streams and click OK. Now we can see that we have remained with data within our map canvas. We have remained with only data containing rivers and presenting rivers and streams, as you can see. We can also choose to name these rivers so that we know exactly where is our river of interest. For instance, let's try to go to properties, and we can go to labels. Then we can choose single label, and within the value we can place name, because we wanna visualize this layer based on names. So we can choose the text size, and we can choose the format, and we can place a buffer. Then we can click apply and OK. Now you can see that our focus is in Msimbazi River, and this is the Msimbazi River. As you can see, this is the river that we want. Our focus is in this river, Msimbazi River. So another thing we can do is we can filter by select by attribute within the query builder using the attribute name, which is Msimbazi River. For instance, we can just go within the layer and try to filter it again. Then we can clear. If you clear, you see the remaining data. The previous data layer is preserved as the way it was, because we didn't save the layer after filtering. So we can now choose. We can just choose. We can choose. We can go to name. Just go to name. Can choose name is equal to, then we can click all and type Msimbazi Here it is. You can see we are having Msimbazi River here. We can click this one. We can just click okay, this is equal to Msimbazi River, or there is another option here of another Msimbazi River, which actually is another feature of Msimbazi River, or name is equal to this one here. Then we can click OK. Now this is our river. As you can see, this is the Msimbazi River. So what we can do now, we can just click on the layer and we can export the layer and save it as Msimbazi. So we can give a name from the file name here. We can name it as Msimbazi. We can browse to the directory that we want and we can name it as Msimbazi. This is Msimbazi River. Then we can click save. We can also choose the coordinate reference system, the one that we want. For instance, we can choose the output coordinate system to be projected. So you can project it. For instance, we can choose ARC. We can type here ARC 1960 UTM zone 37S. This is the UTM zone of the country, you see Tanzania, in this part, including the location of our case study. So we click OK, then we just click OK, and here we have a saved layer called Msimbazi River. So we can uncheck this layer and we can play around with the other symbology of this layer. For instance, we can go to properties and we can choose this blue line, simple blue line here, and we can increase this size of our width. Then we can click apply, then you can click OK. Now you can see this is our river. Again, we can name this layer. We can provide a name of this layer, for instance, by going to properties and labels. Then we can label, single label, we can choose name. Then we can choose the color that we want. For instance, let's choose white and a buffer with a black color, for instance. Then we click OK, and you can see the name of our river is here. If you zoom in, you can see the name. If you zoom out, you can see the name is here. So after this stage, we can now add our land use layers. For instance, these are our land use layers. So we can simply add our land use layer, and what we can do is we can try also to play around the symbology of this layer. But before that, we have to create a buffer to present areas at a certain distance from the river. For instance, given the fact that the government policy requires that people should not construct any development project from a distance of 60 meters from the river, for instance. So let's click the layer that we want and go to vector. Then we go to geoprocessing tools. Then we click buffer. Now we can choose the distance that we want. For instance, as we said, we want to have a 60-meter buffer, for instance, and you can also choose it to be in the unit that you want, for instance, kilometers, feet, miles. Let's reserve the meters. Then we can check dissolve so that all the segments are computed and are dissolved as one segment, as one feature. Then we can click on run. Then here we are. Now you can see that this is our river and this is a buffer of 60 meters. Now we can also name this buffer layer so that it doesn't confuse us. We can also name this buffer layer, for instance, this is 60. This is 60 meter buffer, for instance. And also we can try to create another buffer, for instance, of a certain distance that we want, but for now let's preserve the way it is and let's try to add buildings and other land use types. For instance, let's try to play around the properties of this layer, for instance, the symbology, and we can for instance do this. Okay, let's try to symbolize it. We can go to categories. Okay, let's try to symbolize this layer by going to properties. Then we can categorize this layer, for instance, based on land use type. For instance, we can choose land use type. Yes, we can choose land use type, for instance, and click classify. Then we can click OK. So now you can see that we are having our river, and these are the nearby land use type, as you can see. Now, because we have chosen land use type, we are not able to see buildings because we have filtered our data to symbolize them based on the land use type. You can see, as you can see. So now let's try to symbolize this layer, or we can even duplicate it, and we can now symbolize one of these layer as, for instance, we can symbolize this layer using building. So let's try to use the attribute building to symbolize this layer, for instance. Just click here and try to look on buildings. Yes, you can choose buildings, and we can delete this all, and we can classify the buildings. Then we can uncheck all other values. Then we can click OK. And now you can see the buildings. The building footprints can be observed. These are the building footprints, as you can see. These are all building footprints. But then, as you can see, their style isn't well, doesn't look a bit nice. So we can just use OSM style. For instance, we can go to this layer and click properties, and we can load the OSM style. Here is an option where you can click it and load the style that you want. For instance, let's browse here. And let's choose building style. These are OSM style, and click load. Then we just have to click OK. We can remove all other values apart from buildings, and we can check OK. Now you see this color is a bit well presented. So now we can try also to look on how we can apply select by location. For instance, let's expand this selection toolbar, and this is the selection by location, where you select features within a specific location. This is an opposite of select by attribute, as the one we have been playing around, selecting filtering buildings from the data that we have downloaded. So here, if I click, this is select by location. Now we can choose the data that we want. Let's first rename these layers. For instance, this is a building layer so that it doesn't confuse us. Let's name this layer. These are buildings. So let's go back and initiate the select by location tool. Then we can choose buildings. Then we can choose buildings that are within our buffer zone, so that we see a building that are or any other development activities which are being conducted within a government restricted area. So let's run the process. The buildings are many, so the process will take a bit of time. So the procedure is complete. We can click close, and if we try to zoom in, we can see the buildings that are within the restricted area. For instance, this part here, if we zoom in, we can see buildings. We can see buildings in yellow color. These are the buildings that have been selected. So all these buildings are actually within a restricted area, given the fact that within the country there is a regulation for water bodies, particularly river, that there are not supposed to be any type of development activities within a buffer of 60 meters. So for our case, you can see these are buildings that are within government restricted areas. These are reserved area for rivers. So you can, as you can see, then you can also save this layer. For instance, you can export and save only this layer, so that you have building footprints of only areas that are within government restricted areas. Well, now we might be also need to add roads, facilities. For instance, we can go to this same layer here, the one we filtered, because we already filtered and we have Msibazi River layer which we have already saved it. So let's try to filter from this data. As I said earlier, this data is containing linear features including water bodies and roads. So we can also filter this layer and have roads. For instance, we can clear this one and we can choose to have roads. For instance, okay, we can choose highways. Yes, we can choose highways is equal to, then we can choose the type of road that we want to see. For instance, let's choose for instance, we can choose primary roads, or we might also need to have residential roads, or sorry, actually I have missed out something. So here I have to indicate also that highway is equal, or highway is equal to residential, or highway is equal to tertiary roads, or highway is equal to trunk, and we can click OK. And now you see we have roads, for instance, and their names, as you can see. Now another thing that I want us to try to look at is from the slide that presented the image of a government or public infrastructure, particularly a rapid bus station that has been affected by floods. And we can also see, for instance, before that, we can try to establish a certain distance from which we have collected data that indicate that those areas are highly affected by floods. For instance, we can choose a certain distance. Let's establish a distance of, let's assume a distance of 150 meters, for instance, or 200 meters. So we can just go to river, and we can go to vector, then we can create a buffer. We can create a buffer of 200 meters to indicate that those are areas that are highly affected by floods. So let's make it 200 meters. Then we can click dissolve, and we can click run, and we can click close. So we see this is our buffer, and we can name it as 200 meter buffer. That's it. And we can also style it. For instance, we can double click it, and we can choose the style that we want. For instance, let's go with this style. We can choose it to have a transparent as fill color. We can choose to have a red color. For instance, we can choose a red color, and we can increase the size of the stroke. And also we can also instead of having it as a transparent, we can also choose a certain red color, for instance that one. and you can click apply, then you can click OK. So now areas within this buffer of 200 meters are areas that are highly affected with floods. And what I wanted us to prove is that we can prove this. For instance, taking this part, I'll show you why I have choose this part here. For instance, this is the part. This is an area that I want because this area is presented with this building actually is presented within our one of our image from this slide. So let's try to add a base map of a Google image, because the image was is highly resolution image, so we can add the Google map and we can see the building, and we can go by and prove that this is the particular building from the image that has been taken using a drone during the period of flooding. So let's do it. Well, let's try to add the Google base map. As I said, here is an option to add the Google base map. So this is the Google satellite. Okay, let's try to uncheck the building layers and the land use layers. Now you see, like, this is the building that is captured during the flooding period. Let me show you from the slide. Now, as you can see, this is the building here during the floods period. So here is the building, and as we see, like, this building, this is the river actually going this direction. So as we have seen, we try to establish a distance of 200 meters, and we see part of this building is within the highly areas that are prone to floods, as you can see from here. So let's go to the software and see. So here is the buildings. As you can see, it is within areas that are prone to flood, though they have observed the government regulation of not constructing the building at a distance that is restricted. As you can see, for instance, these other buildings have been constructed at areas that are restricted. So this is the building, as you can see, but also it is prone to floods, as all this area, as you can see, this green area here is actually an area that is highly affected with flood. And that's it. So from now we can just remove the base map, and we can establish now our final map of showing areas that are prone to floods for flood management activities, and also for the government to see whether which type of infrastructures are affected, and designing mitigation measures. So to finalize this map, we have to go to the project and click new print composer, and we can name this composer as Symbology. Let's name it as flood management or we can name it as flood risk management map. Okay, and again we can choose the properties of our page to the size that we want, and we can choose the zoom to full option. Then we have to click on add. Then we can easily draw a polygon that will contain our map, as you can see. So that's a part of our map, as you can see. particularly for that building. Then what we can do now is we can establish other map elements, for instance, but before that, let's put it 5,000. Put this scale as 5,000. Okay. And then we can add other map elements. For instance, we might need to have an inset map. So we can lock this. We can just lock this layer and lock the style. And we can also choose other layer properties from the drop down menus. For instance, we can expand the grid and draw grids. As you can see, let's make it we can make it 500. These are just intervals. You can establish the intervals that you want. And also we need to choose the coordinate system of our grid. For instance, this actually the map these layers are using ARC 1960 UTM zone 7S, this one. So now you can see the grids are being established. We can put 500 and here 500. So those are our grids, and also we can choose the type of the grids that we want. For instance, you might need to have cross, or you might need to have just markers, or you might need to have any other grid type that you want. Let's go for or you can just simply go for frame and annotation, where you'll just have a frame, and if you draw coordinates, you can just see the coordinates. So let's choose cross, and now we can choose the alignment of our left grid coordinates. For instance, vertical ascending, as you can see the changes, and the right to preserve area for other map elements, vertical ascending. Then we can increase the font size, and we can also increase the distance from the map frame, for instance, and we can increase precision of our coordinate, for instance, as that one. Then let's lock this layer. Okay, before that, let's also put a frame, and we can choose the color of a frame that we want, and we can lock the layer. And now let's go back to the QGIS, and we need to add the data for an inset map. So let's just go to add vector layer, and we can choose to add layer containing administrative boundaries. For instance, the one we downloaded yesterday, for instance, from this layer here. We can choose we can just go and minimize our search to shapefile. Yes, to shapefile. Then we can choose level 2, for instance, then click open and add, then we can close. So that's level 2. Okay, if you zoom to layer, you can see this is the Tanzania layer, for instance. As you can see, this is, and our data is particularly at this area. So now what we need is we need an inset map that will show the direction of our study area. So let's filter this layer to remain with just Dar es Salaam, because that's the part where our study area is being extracted from. So let's go to right click the layer and choose filter. Then we can go to name type 2, name level 2 is equal. Then we can choose no, let's name, actually name level 2 is the district, but if you want region, it's name level 1, so its name is equal to sample, which is Dar es Salaam. Then you can click OK, and as you can see now, we have remained with only data of our, we have remained with the inset map of our area, and we can uncheck this other layer because it's just an inset map. We can also choose to symbolize it, for instance, to give it names and to differentiate the district, as you can see. So let's choose categorize, and we can categorize based on name level 2, the district, and click classify. All other values you can uncheck it, then click apply. Okay, we can even delete this one and click apply. And we can also apply labels. For instance, you can choose single labels, and we can choose to have a buffer, and these are the text, and we can increase the size of the text and click OK. So we can just remove these other data. So there we are. We have to go back then to the print composer first, and we have to add the map again. This is simply an inset map. You can draw here an inset map to the size that we want, and we can also reduce the scale. And if you wanna move the content, you can just use this tool here to move the content, and we can make it 7, for instance. Let's try 7. Okay, and we can put okay, you can choose that scale, for instance. So this is our inset map. We can lock it, lock the style. Then now we can add a legend. This is an option to add a legend. You can just place your legend where you want it. So here it is. This is the legend. Then we can add the title for our legend. This is a legend. This is a legend. And also we can, if we want to do editing from this default legend, we can place we can uncheck the auto update, and for instance we can for instance, we don't want this. Yes, it doesn't represent anything, so you can just we can delete it. We can delete this and we can delete this one. Okay, and we can omit all data that we don't want. And for instance, this one, this is an inset map. You can also you can name it as it is, and it represents the inset map, for instance, or you can have it as a single symbol, the way you want. Okay, so here we are. This is let's hide this one. Okay, we can name it as our case study, as our area of interest. We can name this one as roads. These are roads. So these are roads. Yes, so these are roads. These are roads. And okay, this is a 200-meter buffer, which we can also name it as we can add like high flood risk as a short form. And this one is actually a very high flood risk. You can have roads, and then we have to take road up here. Just have to take it to this part here. We can then minimize this one, and this is actually the land use, and we didn't use it, but we can also use, we can just choose to remove it, or we can, these are the land use type, so we can choose either to omit them or to use them. Let's remove them because they are not present in our layer. So we can also remove the satellite image, and we can then play with adding the columns. For instance, let's try to use 3 columns, and let's split this column equally. Okay, what if we use, yes, we can use 2 columns, for instance. We can use 2 columns, and we can also play around with the fonts size. For instance, these are item fonts. You can add, you can reduce, and other options. So we can close, we can lock the layer, and let's go to add other map element. For instance, the scale bar. We can add a scale bar here, and we can choose the units, and we can also add a segment the way we want, for instance like that. And we can choose where to place it. Then we can add, we can also choose the style of the scale bar, for instance double box, and we can also play around with the symbology if we want. For instance, from the display, you can reduce to this color, for instance. Then we can add another, we can lock it and add another map element, for instance a title. You can place a title here, that this is flood risk assessment Msimbazi River Basin in Dar es Salaam. So we can also, we can choose the font size of, we can choose the font size that we want. For instance, we might need to bold it, then click OK. You can also choose the alignment. For instance, we need it to be located to that location, or a bit to a bottom part, for instance, like that. Let's make it the middle. Okay. Now we can add other map elements, but before that we can also choose the color type that we want, for instance that one, and we can lock it, and we can add other map element, for instance the north arrow. We can make it, we can place it here, for instance like that. We can choose the type of arrow that we want. You can go for the choice of an arrow that you want. For instance, let's go for this one. So that's our north arrow. We can also add some other information, for instance concerning the producer of this map and the coordinate system. For instance, coordinate system, this is ARC 1960 UTM zone 37S, and we can choose to add a developer name. You can place your name from there, for instance, and your mobile contact or email. For instance, let me place my email this time. Then after that, you can just you can increase the font or decrease the way you want, and you can choose alignment, for instance. Then you can place it where you feel like it fit best, for instance that place. Then after that, we can add a neat flame, for instance. We can add a neat flame. We can choose to add a rectangle, and we can add a neat flame. Then we can choose the style to be transparent so that our features are well seen, and we can lock all other layers. And we can now move to its best fit to that place, and we can just if we feel like there are other features that we want to digitize, we can just simply take it to the down place so that we are able to digitize other features, for instance to this part. So we can also we can like, for instance the title, we can click this one, and we can move the title to somewhat here, for instance. Then we can lock it. So that's our map, and I think we have added all other map elements, but also we can choose to add an arrow to indicate a direction where this map has been created from. So it's from here that we have had this map. So you can just okay, we can also change the color to this one, for instance. Even this line, we can choose the color that we want, for instance red. Then we can lock it. The last part is to export, and you can export it as an image, for instance. This is the tool to export an image. You export as an image, and you can choose to have flood risk map. Okay, you can add Symbology. and you can choose the image format that you want. For instance, this one is JPEG, but if you click here, you can choose the format that you want, and you can then save. Then you can choose resolution that you want, then you can save. So you can see our export is successfully exported to this directory folder, and the name and the and actually the image format .jpeg. So let's go and try to export it as a PDF in case we want to go and print it somewhere else. For instance, we can we can add Msimbazi. We can add Msimbazi. We can remove the .jpeg. Then we can click save and save. So you can see now our export is also successfully, and if you click here, you can go directly to, you can try to go directly to the folder and the image will appear. As you can see, here is your image. So you can just open it. For instance, let's try to open it. So here is our PDF map, as you can see, and you can just go and print it. Yeah, so there it is. Thank you for watching, and